My name is Don Reed. I'm from Leidos, and today we're talking about PTL, or Positive Train Location, which is a technology Leidos has been developing in sponsorship by the FRA for the last few years to provide position and velocity information to the locomotive in areas where a typical GPS receiver would not function within, such as inside a tunnel, under overpasses, those types of things. So that allows PTC to continue to operate in areas where a typical GPS receiver would fail off and they wouldn't have position information. PTL will provide position and velocity information in those restricted areas. And with an end-of-train and head-of-train unit, they'll also have the actual length of the train. So in the future, if people want to implement rolling blocks, that would allow that to proceed forward. Currently, we're just finishing up our initial testing, our last testing phase, and we are now moving into a reliability phase where we're going to put 50 to 100 units out in the field in preparation for going to production later this year. So we're here for the PTC World Congress to give an update on the testing from PTL from last year to this year, and to introduce new technology that we're working on for wideband software-defined radios to improve the communications link between the end of the train and the head of the train.
So my name's Rich Engert. I'm with Leidos in St. Petersburg, Florida. I'm a Chief Systems Engineer for Leidos. I'm here today to talk about the wideband software-defined radio that we developed originally for a military customer, and we're looking to apply that to some of the railroad communication requirements. Well, some of the features that we've designed into the system include a cognitive type autonomy, such that the system is able to decide what the best frequencies are to use, and what this winds up doing is providing a better throughput and bandwidth for the railroads in terms of overall throughput. And it also adapts autonomously to avoid situations where there may be interference, or maybe there's a better use or a higher data rate, and the system's able to sort of automatically decide what the best course of action would be without requiring an operator intervention. What we hope to do is, overall as a product, prove that we meet all of the harsh requirements for the military. And then on the railroad side, if we can demonstrate the feasibility of being able to make use of multiple frequencies, such that the overall aggregate bandwidth available to the locomotive or to the railroads in general is optimized for whatever the situation is that's presented for that scenario.